Welcome to the lecture number 62, dear students. So last time we have studied inscribed angle theory. Now this time we are going to study the applications of inscribed angle theory. So this is the first application, you can say, that angles inscribed in the same arcs are congruent. Try to understand the meaning of this. I have already explained you what is the meaning of inscribed arc. Inscribed arc, in short, you can say this arc is like a cover. Okay, this arc is like a cover on the angles. And very important thing, that vertex of the angles lie on a circle. These two are very important points. That vertex of the angles lie on a circle, and second point is that this arc acts as a cover. If you remember these two things, then rest of the part is very easy to understand. Okay, let's see now. Angle ABC. Angle ABC. You will notice that B is lying on the circle. Correct? Because that is as per the definition of our inscribed angle. Likewise, you will find second angle is angle ADC. For angle ADC also you will notice the same thing, that vertex D is lying on the circle. So this is how first condition is satisfied, that angle ABC and angle ADC are inscribed angles. I think this is very clear to you. Now next to that, we have to prove that these two angles are congruent. Angle ABC and angle ADC. Now this arc ABC is called as inscribed arc. What is it called as? Inscribed arc. And angle ABC and angle ADC are inscribed in the same arc. Okay, that is what is given. Now you will notice, by inscribed angle theorem, angle ABC is equal to, now arc AXC is called as intercepted arc. Try to understand the difference between these two terms. One is called as inscribed, while other one is called as intercepted. Intercepted arc is an arc which facing the angle. Correct? And inscribed arc is an arc which covers the angle. That is the difference between inscribed and intercepted. Okay, so you will find angle ABC. Now, since you will find with the sides of angle ABC, namely AB and BC, which arc is intercepted? AXC. So by inscribed angle theorem, you all know angle ABC is equal to half major arc AXC, isn't it? We label it as result 1. Not only that, you will find we have also mentioned over here reason also, inscribed angle theorem. Likewise, you will also notice the same thing, that angle ADC, this angle is also called as inscribed angle, in which are ABC. You may think, why not ADC? Yes, you are, even in that case also you are correct. So you will find angle ABC is equal to half major arc AXC. But what is arc AXC? AXC is called as intercepted arc. For which angle? For angle ABC as well as for ADC. So what you notice here, if you compare results 1 and 2, surely you will find right hand side is half major arc AXC, as well as here also right hand side is same, half major arc AXC. So this gives us a very important conclusion. What is it? LHS is equal to RHS. In today's way of teaching, they don't call it actually LHS is equal to RHS, but still you will find, simply for clarification we can say. So you will find right hand side of 1 is equal to right hand side of 2. And hence left hand side of 1 is equal to left hand side of 2. So angle ABC is equal to angle ADC. That is what we have to do. So ultimately what we got a result, that since angle ABC and angle ABC are inscribed in the same arc ABC, that is why their measures are same. So this is a very important application of inscribed angle theorem. Okay. Now I am going to proceed for the very important theorem. Very frequently this theorem has been asked in the examination, which is called as cyclic quadrilateral theorem. Very important theorem from examination point of view. Please try to understand this theorem carefully. This is so important theorem, more or less you will find if you go through all the answer sheets. Solutions, you can say, solutions of different question papers, which you will find in most of them they have asked this theorem. In most of the question papers, you will surely find this opposite angles of cyclic quadrilateral are supplementary. Very famous, very popular theorem. Try to understand this theorem carefully, because weightage is also very good. If this theorem will be asked in the examination, then actually you will find weightage for this will be of 4 marks. Please see here, dear students, I am writing statement first. Statement of the theorem. Statement is opposite angles of cyclic quadrilateral opposite angles of cyclic quadrilateral are supplementary. Very important. Okay, now I am going to draw figure first, as usual. Since you all know the definition of cyclic quadrilateral. Cyclic quadrilateral is a quadrilateral of which all vertices are lying on the circle. Okay. So here you will find, if I draw this circle, and in this circle if I draw cyclic quadrilateral, okay. So it is given on the same page, correct? 68 only, that opposite angles of cyclic quadrilateral are supplementary. Now opposite angles of this quadrilateral ABCD are A and C, as well as B and D. So what we have to prove, first of all I will given as usual. These all terms are very important because in theorem, these all minute things are always checked, whether given is written or not, whether to prove that is written or not, if construction is necessary, whether that what construction and whatever constructions you have done that is written or not. So half of mark distribution is there for all these points. So why to use this mark? So we have to be very particular in writing all the things. And as I stated earlier also, that whenever you will write the proof of the theorem, you should write same as it is given in the text. So that is mandatory. So you will find given quadrilateral ABC is cyclic. Cyclic means all its vertices are lying on the circle. Okay. Next point. To prove that angle A plus angle B is equal to 180, as well as angle A plus C, opposite angles A and C, as well as angle B plus angle D, that is equal to 180. Because you will notice B and D are opposite angles, as well as A and C are also opposite angles. Okay, now let's begin with the proof. Now you will find in proof angle, first reason A plus C. So angle A is equal to half measure R. Now please try to understand, dear students, that A is inscribed angle. Why to call it as an inscribed angle? Reason is very simple. Since its vertex is lying on the circle, that's all. That is the required basic condition to be angle A as inscribed angle. Okay. Now if you see the sides of angle A are namely AB and AB. So because of at the end of the side AB, which arcs begin over here? Arc DCB. Likewise from this side, which arc is there? BCD. One and the same. These arcs are one and the same. So you will write here angle A is equal to half measure arc DCB, or even you can write BCD. Half measure arc BCD. If I label this as 1, okay, this is called as inscribed angle theorem. I am going to write reason also over here. Inscribed angle theorem. Right? Now we have to get angle C, because first result is A plus C is equal to 180. So second one is angle C. So angle C is equal to half measure R. Now please see here for angle C. Angle C is also inscribed angle. Why? Same reason, that its vertex is lying on the circle. C now. Now C is formed by the sides DC and BC, isn't it? And you will notice from point D, which arc begins DAB, see here, and from side CB, where it ends at point B. From there also you will find the same. So I write here angle C is equal to half measure R DAB, which are DAB. If I label this as result 2, same reason we have to write that inscribed angle theorem. Inscribed angle theorem. Same reason. Okay, dear students. Okay. Now come to the results. What we need to get? A plus C is equal to 180. Now to get A plus C as 180, left hand side is what? A plus C. So obviously we have to add equations 1 and 2 to get A plus C. So I'll write over here adding. Okay, I'll write over here adding equations 1 and 2. and in equations 1 and 2. So if we are going to add equations 1 and 2, left hand side of 1, which is left hand side of the equality sign. So A plus C, angle A plus angle C, that is equal to angle A plus angle C, that is equal to half measure arc BCD, half measure arc BCD plus right hand side of 1 is half measure arc PCD. Likewise, right hand side of 2 is half measure arc DA. Half measure arc DA. So this is how you will find. I add left hand side of 1 plus left hand side of 2. I want it as A plus. Likewise, right hand side of 1 plus right hand side. Now, very easily you can notice one thing, that half is a common. Half is a common and these two terms are separated by plus sign. Correct? So, I'll take half as a common. Then, inside the bracket, if I take half common from here as well as I take half common from there, from first set as well as from the second set, then I left with measure arc BCD plus sign will remain as it is, plus measure arc A plus measure arc DA. Okay. Now let's look at the figure. Okay. Let's look at the figure. So next step is half as it is into. Now please look here, students. BCD. Okay. So I'll begin from B. BCD till here we reach. Isn't it? See, we're beginning from B. BCD. Okay. Now next one is what? DAB. Okay. D, I'll begin from DAB. What happens? We begin from point B and we end also at point B only. So it completes the circle. Try to understand again. RBCD plus RDA. That gives us complete arc, means indirectly we got complete entire circle. And we will surely find the sum of all arcs of a circle is 360. Okay, so I am going to write 360. So half into 360. Let's cancel it. 2 into 180. So you will get angle A plus angle C, that is equal to 180. See, to prove that angle A plus angle C is 180. That is what we have to do. What we have to put, that opposite angles of cyclic quadrilateral are supplementary. So we got the result. A plus C is equal to 180. There is no need, even in the textbook also they have mentioned, to get the second result, simply you have to say that similarly. Okay, what you have to say? Similarly, angle B plus angle D, that is equal to 180. Similarly, you have to say. That's all. You don't have to prove, or you don't have to go through the same thing. Very, very important theorem from examination point of view. I repeat all these again. Okay, please have a look here. Seriously, that statement, opposite angles of cyclic quadrilateral are supplementary. That is what we have to prove. So given quadrilateral ABCD is a cyclic quadrilateral. Okay, that is what I am doing. To prove that opposite angles are A and C as well as D and B. So A plus C is equal to 180 as well as B plus D is equal to 180. Please have a look here. You look at the proof. I will explain it from the figure. Okay. So angle A. Angle A has intersected R DCB. So I will get here angle A is equal to half R DCB. Likewise, angle C is equal to half R DAB. For both these, I will give a reason. What reason I am supposed to give? that is square angle theorem. Since I want a plus c, I stated over there adding equations 1 and 2. Then I get a plus c, that is equal to half measure of dCb plus half measure of dA. Okay, then taking half as a common. If you take half as a common, then you will get r dCb plus r dA. And finally we will get r dCb and r dAb. If you add both these arcs, you will be getting circle. And measure of all arcs of the circle or total circle is always 360. So 1 upon 2 into 360 is 180. So A plus C is equal to 180. For second result, second is also a pair of opposite angles. There is no need to write this entire proof again. You simply have to mention similarly angle B plus angle D is equal to 1. So that's all, dear students, for this very important term, which is called as opposite angles of cyclic quadrilateral are found. Now you will find there is converse is given. Converse is given that if a pair of opposite angles of this quadrilateral are supplementary, then it becomes cyclic. There is no need. It's okay. Right, now one more theorem is there on page number 70. I am simply explaining you because proof of that theorem won't be asked in the examination at all. It's very simple theorem. On page number we will find it. Page number is 70. Page number is 70. Okay, dear students, now let's see that this theorem which is given on page 70. Page 70. One line is given. One line is given. And on this line, 2 points are given. Figure number 3.50. Please look at the figure 3.50 on page number 70. So you will find here, statement is very important. This is figure 3.50. ABC. And I think ABC. Now, statement of the theorem is very important. Statement is as such that if any 2 points on a given line, okay, if any 2 points on a given line subtends a congruent angles on the same side of the line. I repeat again the statement very clearly that if any 2 points on the same line subtends congruent angles on the same side, now upside of this AC. Now 2 points are there on line A and C, and they are subtending, means indirectly they are forming. Subtending means what? They are forming. So you will find angle B and angle D, which are congruent angles. Okay, they are subtended by points A and C on the same side of its upside. In that case, you will find if these angles are congruent, then these points are concyclic. Now try to understand the meaning of concyclic. Concyclic means not so different things. Means these points A, B, C, D are lying on cyclic quadrilateral. That's all. What is it? That points A, B, C, D are lying on cyclic quadrilateral. But what is the condition? If any 2 points on a line subtend means form congruent angles on the same side of the line, then those points are coincident. Now indirectly, very easy to understand. What happens here? You will find, if I draw arc, just take an example. If I draw an arc passing through A and C, then what will happen? Angle B is equal to half arc AC, as well as angle D is also equal to half arc AC. Finished. So these points are coincident. There is no need to find out the proof of this theorem as well as to write the proof of this theorem. These all things are not required completely. Only you have to understand the concept that if same points form a congruent angles. Fine, dear students. So now next to that, okay, I think we should begin exercise 3.4. After this, there is exercise 3.4. Please look. Page is not 70 now. Page is 73. Exercises. I am going to mention exercise 3.4. Exercise 3.4. Question 1. Question 1. In question 1, circle is given. Center of a circle is O. Center of a circle is O. Okay. Now please look at this figure. In addition to this, they are given us length AB is equal to radius. That is very important. So given length AB is equal to radius. Okay. And in addition to that, nothing is given. Then we have to find out. We have to find out angle AOB, angle AOB. Second one is angle ACB, angle ACB. Third one is there arc AB, arc AB, and fourth one is arc AC. Okay. This is a perfect question for 3 marks or 4 marks. Okay, alright. Now what is given? AB is equal to radius. If I call this as R, because it is given only. Then you will find in addition to that, if O is a center, then you will also find OA is radius as well as OB is also radius. So now what happens if you look at the figure? If you look at the figure, then you will find OA is equal to R, OB is also R, as well as AB is also R. So triangle OAB is an equilateral triangle. Try to understand. If AB is R, this is already radius, this is also already radius because O is given as center of a circle. Therefore, triangle OAB. Okay, I am going to write now answer. OA is equal to R, OB is equal to R, AB is equal to R. Therefore, triangle OAB is an equilateral triangle. Is an equilateral triangle. You all know the definition of the equilateral triangle. If all three sides are congruent, then it becomes equilateral triangle. Now, if it becomes equilateral triangle, this angle is of 60 degree, this angle is of 60 degree, as well as this angle is also of 60 degree. So I write here angle AOB is equal to 60 degree. Why this is 60 degree? The reason is very simple. Because it is an angle of an equilateral triangle. And you all know, all angles of equilateral triangle are always 60 degree or congruent. Okay. Now see, next thing. What we have to find out? AOB only. So our first answer is there. This is how we got our first answer, that angle AOB is equal to 60 degree. Second one is angle ACB. Okay, CB. Try to understand. Angle AOB is equal to measure R. I am going to label this as X. Is equal to measure R what type of angle AOB? Vertex of the angle is at the center and such type of angle is called as central angle. Correct? And measure of central angle is always equal to the intersected arc, and therefore angle AOB is equal to measure arc AXB, and that is equal to 60. We call it as central angle. Central angle. Correct? Angle AOB is of 60 degree. Arc AXB is intersected by central angle, and therefore AOB is equal to arc AXB, and that is equal to 60. Okay. Now this is how I got this arc AXB as 60. Now what is the next question? Angle ACB. Now look at the angle ACB. Angle ACB, vertex. Position of the vertex is very important for us. Vertex is on the circle, right? Vertex is on the circle. So this angle is called as inscribed angle, and sides of this angle are AC as well as BC. They have intersected arc AXB. This is very important to understand. that angle ACB has intercepted the arc AXB, and therefore measure of angle ACB is equal to half measure of arc AXB. That is very important. And this is called as, I am going to give reason for this. This is called as inscribed angle theorem. Inscribed angle theorem. Okay, then this is equal to half as it is. But we know the measure of AXB. We know the measure of AXB is same as that of angle AOB, and that is equal to 60. Please look here. That is equal to 60. So 230 is out. So angle ACB is equal to 30 degree. This is our answer of second question. What is angle ACB? So we got it as 30. Next to that is arc AB. Okay. Arc AXB, I have already got it here. So third one, measure angle AOB is equal to measure arc AB, that is equal to 60. Central angle. Central angle. So our third question answer is measure arc AB is also equals to 60. Correct? Now only one question is there. Arc ACB. Arc ACB is this one. Arc ACB. Sum of entire circle is 360. Out of which I know AXB. AXB is how much? 60. So naturally 360 minus arc AB will give us measure of arc ACB. And it is going to be a 300. Very simple. So here I am going to write now. Measure arc, please try to understand. ACB is equal to 360 minus measure arc A. Sum of arcs of a circle. We must give reason. Sum of arcs of circle is equal to 360. Okay. So what I write now? Measure arc ACB is equal to 360 minus measure arc AB. So measure arc ACB. I am going to continue. Measure arc ACB, that is equal to 360 minus 60. That is equal to, of course this is very easy. So measure arc ACB is equal to 300. Very simple sum in that way. But only important thing is that if AB is on, then AO is on, this is on, triangle AOB becomes equilateral triangle. Therefore angle AOB is 60, as well as this is also 60, this is also 60. But that is of no use for us. We are concerned with only angle AOB. So if angle AOB is 60, naturally we will find that if this is 60, our AXB is also 60, central angle there. Angle ACB is inscribed angle, that is equal to half arc AXB. So half of 60 is 30. Okay, that is also over. Then next to that, AXB plus ACB is 360. But since we know AXB is 30, sorry, AXB is 60, so 360 minus this 60 will give us ACB as 3. That's all. We will start. Okay, now time on dear students. Here I have finished first question of exercise 3.4. Naturally, next time we'll do next question, that is the second one. But very important to tell you all that theorem of cyclic quadrilateral, property of cyclic quadrilateral, that opposite angles of cyclic quadrilateral are supplementary is very, very important theorem from examination point of view. Thanks a lot dear students for listening this lecture carefully as well as for watching this video. God bless you all.